In this video, we'll generate the trend line and trendline polynomials of the Q function using Taylor-Maclaurin series sum, complementary error function, and the Linus polynomial regression. We begin with the Taylor-Maclaurin series sum expansion of the Q function, which is equal to 0.5 plus the summation of a times x over square root of 2 raised to the power 2n plus 1 over square root of pi, where a, the coefficient, is equal to negative 1 to the power n plus 1 all over n factorial times the quantity 2n plus 1. And our value of n will be from 0 to infinity. In this case, we can go as far as 16. And we continue with the coefficients. So R, the formula, minus 1 raised to the power the quantity n plus 1. That's n plus 1 all over the two parts. The quantity, the first part will be factorial n. Times the second part, that's 2n plus 1. So 2 times n plus 1. And we can now complete the expansion, which is RA formula series sum of the x values over square root of 2 raised to the power 2n plus 1, where 2n plus 1 starts from at n equals 0, so 1, followed by 2 times 1, 2, 3, so 1, 3, 5, 7, 9. So starting from 1, incremented by 2. And the coefficient will be this range. Enter. And we factor in square root of pi. So the whole expression, series sum expression, divided by square root of pi. And we add 0.5 to series sum. So 0.5 plus series sum. Now we'll chart this. Insert chart. And we will use scatter chart for this. Scatter chart. Use row 1 as headers. The series will have a trend line, which is polynomial to the 8th degree, and the label will be the equation. Legend position will be at the bottom. And here's our trend line and trend line polynomial of to the 8th degree. And we continue with the complementary error function, R, a formula, ERFC of the x values, as well as the error function, R, a formula, ERF of the x values. And we'll modify the chart to show the trend line polynomial as well. So customize series, the trend line polynomial to the 8th degree. Use the equation as label. And we change the color of the error function polynomial, ERF, to green to match to our data set. So here we have the polynomial and the trend lines. Next, we'll calculate the regression coefficients using LINEST. To do that, we complete the LINEST matrix starting with the power transpose from 0 to 8. And now we enter the elements of the matrix, R a formula of the x values raised to the power 0 to 8. Enter. Now we can enter LINEST. So LINEST with the expansion data y and data x and the complementary error function, which is LINEST data y and data x. And finally, the error function, which is equal to LINEST data y and data x. Enter. So here we have the trendline polynomial regression coefficients. Now we modify the complementary error function, which is there's a square root of 2 in the x. So x divided by square root of 2. Square root of 2. So the red now is closer to the blue. Then multiply by zero point 0.5. So zero point 0.5 times ERFC or error function, the complementary error function. Now they're all in the same trend line. Their data sets are the same. Their polynomial regression coefficients are the same. We continue with the error function. Again, there's a square root of 2, so that's divided by square root of 2. Square root of 2. And then we factor in 1 minus ERF. So that's 1 minus ERF. Then we multiply 0.5 to the whole expression. So that's 0.5 times for the whole ERF function. So enter. Now they're all in the same train line. Their data sets are all the same. The polynomial regression coefficients are also the same. So the coefficient for x to the 0 is 0.5. The coefficient for x is minus 0.399. The coefficient of x squared is, this is 0 because 1.98 times 10 to the minus 19 is already 0. And 2.51 times 10 to the minus 17, 2.5 times 10 to the minus 17, these are 0 already. X cubed, 0.0656, that's 0.0656. X to the 4th is 0. 1.08 times 10 to the minus 18, that's very small, that's already 0. 1.19 times 10 to the minus 16, that's already 0. Then continue with x to the 5th. 8.79 times 10 to the minus 3. That's 8.79 times 10 to the minus 3. And x to the 6th, 0. This is 1.23 times 10 to the minus 18. That's very, very small. That's already 0. 7.93 times 10 to the minus 17. 7.89 times 10 to the minus 17. These are very small values. They are all 0. And x to the 7th. That's 5.98 times 10 to the minus 4. 5.98 times 10 to the minus 4. 5.98 times 10 to the minus 4. X to the 8th is 0. 3.52 times 10 to the minus 19. That's very small. It's 0. 1.28 times 10 to the minus 17. 1.27 times 10 to the minus 17. These are already 0. So this completes the use of error function, complementary error function, Taylor-Maclaurin series sum, and Linus polynomial regression to generate the Q function dataset, trendline, and trendline polynomial.